All right.
All right.
EP117. Welcome to the Hackaday podcast. My name is Mike Szczys. I'm editor-in-chief of Hackaday.
Hey, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 117. Today we're talking about Chiptunes in an RCA plug, an Arduino floppy drive, $50 CNC, and wireless switches.
Let's see, we got some crazy news this week. It's gonna be raining rocket parts. Last week, Tom wrote up breaking news about China's Long March 5 heavy lift rocket. They had just shot something up into low Earth orbit and they lost control of the rocket. Unlike a lot of other rockets, this one doesn't split in two, so there's no like first stage, second stage thing. It's the whole thing. So it's a big chunk of rocket up there, and it is unfortunately tumbling out of control and is probably going to make an uncontrolled reentry sometime real soon now. So
my guess is if you're listening to this, it's already happened because it's gonna happen any moment while we're recording.
It
the
could
podcast.
have happened now. It could happen tomorrow.
And they have a better idea. They think most of it's going to hit the Pacific, but there could be some on land.
That would be fantastic. I've already got my reinforced steel umbrella though, so I'm cool.
You have a steel umbrella.
Of course, man. It's going to go right through a regular umbrella. What are you even thinking? But what's shocking to me is how this happens, actually. There's actually debris from a SpaceX Falcon 9 that landed in Washington State not that long ago. They've dropped stuff on Indonesia before as well. It's a little bit terrifying to me to think of all the things falling down from space on us. But to their credit, they try to land these things in the water when they can. And it's a rare circumstance when they don't. But this Chinese rocket is the biggest thing to lose control so high up since like Space Lab, I think, which fell down in the 70s.
Oh, you know what? Now I have a page open that's saying they still don't know where it's going to land and they think it's going to come on Saturday. So ignore my previous incorrect statement.
Who's looking good with his umbrella now?
Yeah, well, we've been told about this for a long time, right? That space is getting crowded around that low Earth orbit has a lot of stuff around it, and we keep putting up more stuff around it, and what goes up eventually must come down. So it's not a surprise that this is happening. It's more of a surprise that we haven't figured out a way to better deal with these things.
It is a surprise that it's happening. This is a mistake. This should not happen. They should send these things down at a slanty enough trajectory that they burn up in the atmosphere. They should not lose control of their super gigantic vehicles in space and just have them fall down, wherever. I contradict you. This is actually a big deal. The good news is the Earth is mostly covered with ocean, and this stuff is just going to end up in the water somewhere most of the time. Stainless steel umbrella.
That'd have to be a pretty thick umbrella, Elliot.
I think if you knew it was going to go down anywhere near you, you would stay indoors.
Yeah. Could it punch a hole through your roof?
Yes.
You want to flip a bathtub over and be underneath it. Stainless steel bathtub.
You're probably more likely to win the lottery than to get hit by falling space junk. So in that sense, it's not a super big deal.
That reminds me of something someone said in the comments where they said, falling space debris never hit anyone. And someone replied and said there was a meteor strike that hit a woman.
Yeah.
And the meteor was worth a lot of money then.
Right.
It was like winning the lottery in a really bad way. So that meteor strike, Elliot?
Mm-hmm.
That's the Silakuga meteorite, and it fell on November 30th, 1954, and it's commonly known as the Hodges meteorite because a fragment struck Anne Elizabeth Fowler Hodges. There is a piece of history for you. We will put that in the show notes so you can read all about it.
Well, how are we going to segue into this thing?
We need music.
This is a journey into sound.
What's that sound? What's that sound?
What is that sound? Sounds like Pink Floyd.
I wanted to do quizzes of like, here's some old equipment. What is it? And then I was like, oh, they can't see any of it. So we have to do audio clips of old, interesting, quirky electronic mechanical equipment. And you all have to guess what it is. Send in your guesses to Where?
Oh yeah, let's put a link in the show notes to a Google form, and you can put any email address you want and your answer. We should probably have a prize, Elliot.
How about, do we have any Hackaday podcast t-shirts?
You can have the first ever Hackaday podcast t-shirt. If you get the right answer, and then we'll take all the right answers and we'll draw one person on next week's show. And that's why you're going to have to give us an email address so we can actually get back to you. But yes, we will figure out how to come up with the most awesome podcast t-shirt ever, since we've never had a podcast t-shirt. And we will send it to you if you can name this sound. All right, so if you know what that sound is, go to the show notes, hackaday.com/podcast, and there's going to be a link to a Google form. Put in your email address and what you think that sound was, and we will draw randomly next week from all the correct answers one person who will win the first ever Hackaday podcast t-shirt.
I think I'll have to make up some kind of quasi-Rube Goldberg-y random number generator to do this.
Oh, I like that idea. So join us next week for that. In the meantime, Elliot, let's jump into the hacks.
Let's go.
Oh, I love this first one so much. RCA plug plays 16-minute chiptune piece all by itself. So the first thing I did was just put the YouTube video on in the background, and the music is good. The hack itself is a little RCA plug. So this is just one that you plug in, so it's mono. It's totally self-contained. There's no cord coming out of it. If you look inside of it, Elliot, the reason I picked this one is the Flex circuit board. This is an awesome example of using Flex PCB. There needs to be a power source because these plugs don't have power through them. They're purely audio signal. And in this case, one Flex PCB has like two circles and is connected by a piece of Flex PCB in the middle so that you can sandwich it around a coin cell, and that powers it just from the pads that are on those two bits of the coin cell. On the back of it is a tiny little 6-pin microcontroller, and all of it fits inside of the housing that would normally be like strain relief for these cables.
Now, I love this thing, but I will take a little bit of exception to calling it chiptunes. This is one of those algorithmic things again, where they do all the like bit shifting and XORing. It's basically a bad like random number generator routine that generates such non-random numbers that it turns out to be music. If you click through to the link to the code, it's essentially a one-liner in Bash that'll play it for you. It's really, really cute. And so you can implement it on essentially anything that can do a little bit of math and toggle a pin to make some noise. So it's a lovely, lovely little hack, and it makes me think of those graphics from a week or two ago that were doing kind of similar tricks with multiplications and modulos and etc. to make those graphics that you particularly loved.
I did. I've actually gone back and looked at those and played with them a few times. That was a great hack.
And so I like to think of this as like the audio equivalent of that.
I think for me, then, the next thing I drilled down on is the use of the microcontroller. So the original version of this was built around an ATtini4, which is 12 megahertz, 4K of flash, only 256 bytes of SRAM, which is where I think things could get a little hairy in it. But really, like 4K of flash and 12 megahertz, that's pretty powerful for this type of use. But don't stop there, because it was then ported to one of those Paddock PMS150C microcontrollers. You probably don't know that number or maybe even that name, but you'll know this as the 3-cent microcontrollers that were all the rage, I don't know, a year or two ago. And these were interesting because they're one-time writable. So they have 1 kiloword or 1024 words of flash memory, 64 bytes of SRAM, and on this 3-volt unregulated supply can only run at 4 megahertz. And I think that's pretty interesting to be able to fit that all in, Elliot.
That's why you use such a small, like, algorithmic music generator, though, right? Like, you could fit this on nearly anything.
This is the anything. This is what you...
Exactly. I was trying to think, well, what would your next step be? You'd put it on a... Oh, there isn't anything.
Yeah, I think Gears said a PIC 10 is the next one. I don't know if that's a joke or not, but I would think this would be less feature-rich than the small ATtinies either. Of course, this plug trick harkens back to Mozilla, and we've run a bunch of Mozilla hacks lately. But going way back to 2015, 2016, Mozilla was working on a microcontroller inside of a MIDI plug. And so I just put those links in here as well. You can go and look at there's one that's the plug only, and it's a synthesizer. So it has a buzzer, like a piezo buzzer. And so you plug it into the back of your keyboard. MIDI, usually you have a keyboard controlling something that makes great audio. And in this case, it's using the MIDI out on your keyboard in order to play a piezo buzzer. And it's horribly awful.
Well, my first hack this week is a soundbar bested by virtual Android Bluetooth sniffer. Michael Yurko of Vane.org has a 7-part reverse engineering and reconstructing extravaganza on a Yamaha YAS207. Like I said, there's 7 posts here. There's a lot to dig into. In the beginning, he starts off trying to hack into its IR remote, and that ends up being fairly simple. Along the way, of course, there's some little fails and some hiccups, and I thought it was really great that Michael documented those for us as well. But at the end of the day, what he does is he uses the IRMP, which is the infrared multi-protocol decoder encoder software library, which is absolutely fantastic. I've used it before. If you want to mess around with anything in IR, it's got like all of the different coding schemes figured out for you. And it turns your blinking lights straight into data and vice versa in short order. So that was his first hack. And then he's like, well, okay, now I need to figure out the Bluetooth. And so he gets himself a Bluetooth LE dongle, but this is regular Bluetooth. So you could skip over that post. It goes into the beginnings of understanding Bluetooth. And then he decides that what he really needs to do is to use the original Yamaha app and then sniff it speaking Bluetooth to the device, but he doesn't have an Android phone. So he pulls down an Android emulator, runs it on that inside a VM, and then kind of man in the middles the VM while he has it talking to the device. And that's just a marvelous technique, because when the software / running system that you want to attack is inside a VM, you basically control everything and it doesn't know any better. So that's a really cool part of this hack. And then it ends up with him building up his own infrastructure around it, which I guess, since he is an Apple guy, includes some sort of airport clone called SharePort, which then takes audio directly from his phone and over, well, oh yeah, he also reverse engineered the Toslink, the light communication, which is basically I2S. Uses the Toslink to get audio into it so he can control it with a Raspberry Pi and his cell phone. Play audio straight to the Raspberry Pi. Raspberry Pi pumps it to these speakers, and boom. This is just a complete, from bottom to top, reversing, owning, and bending to his will of this poor little Yamaha YAS207, whatever that is.
Well, I think this is a good thing to have under your tool belt, because it does feel like it's so closed off when you're doing something that is like a dedicated phone app. Like, how are you going to get that information? And so this trick of running Android on a basically desktop computer is a really good one. In this case, he's just piping out the Bluetooth packets that he's sniffing directly into WireShark. And so it's like using the VM itself as your avenue for getting the data to WireShark, which a lot of people have used that before. It works across so many different platforms.
Lovely hack, full of little nuggets, full of also, like I said at the beginning, full of also a lot of dead ends that he takes you down anyway and tells you they were dead ends. And so, you can learn from his mistakes as well. Yeah. All in all, if you want to start working on some consumer gear and you don't know where to start, this is one you should be reading.
Big Clive has been tearing down the secrets of batteryless remote switches. And I looked at this and I kind of had the same idea that Big Clive does. I have a doorbell that has the actual button on the outside of the house, has no battery in it at all. And you push it and it kind of clicks closed. And I associate it with, like, those barbecue grill lighting mechanisms, Elliot?
Yeah, little barbecue piezos, right?
Yeah, so like a piezo would make a spark, and that would light the gas on your barbecue. And I assume the way that the doorbell in my house works is that spark is then captured and turned into the electricity needed to actually send the wireless signal to the receiver. But in this case, Big Clive found out this is not how it works on the switches that he has. He tears them down, and they have a really interesting magnetic setup. So there's kind of like a U-shaped piece of metal, and then it has a magnet with kind of an iron plate on either side. And so when the magnet is moved up or down, it contacts a different side of that U-shaped piece of metal, and at the same time moves the magnetic field past a coil, inducing what must be an incredibly tiny bit of current, Elliot. It's just
Blows
shocking.
my mind.
Yeah, I would think that you would need to move a certain distance, or you would need to have a really huge magnet, and like neither of those things are happening in this case. Clive traces out the entire circuit for this thing, and it's just very simple. Like, it's a 3-switch unit, one chip inside, so the 3 switches are just attaching to it. You basically have a bridge rectifier, because the magnet could be moving, up, or it could be moving down, and that's going to change the polarity on your inductive coil. And so, with 4 diodes, you can make sure that the positive always goes to the high rail and the negative always goes to the low rail. But then you have to figure out which switch was being moved and in which direction. And so there's kind of like, I don't know, would you call it a center tap?
Yeah.
A diode, coming off of the center of the coil to see which polarity was used. And it only reacts to, when that side of the coil is positive. And that feeds into a specialized chip that then goes to the transmitter.
When you told me you had a doorbell thing that didn't require any batteries, I almost didn't believe you. But this thing, and I almost don't believe this, except now I've seen it, so I really have to believe it. It's really wild. It's a traditional generator, but it's just the act of pushing this thing through fairly quickly, I might add, that charges up some caps and then feeds a voltage regulator, and that feeds the little transmitter, and then Bob's your uncle. I am completely surprised that works. And it led me watching some of his other videos on these kind of self-powered switches. And he has picked up some that were piezoelectric, like you were suggesting. And I thought that was kind of cool too. But this one it's just a little generator.
Yeah, it makes a ton of sense, because those switches are sitting around all the time. Like, there's no reason to need power if you can get away with it. I would see some other energy harvesting thing like a calculator style solar panel just getting ambient light or something. I guess the problem is, what if you depress your stored, deplete your stored supply, then you can't switch your lights. So in this case, I suppose the actual act of going one way or the other. I mean, wouldn't it be interesting if in our lives to turn lights on or off, you had to turn a crank in order to generate some electricity?
Yeah, I was going to say, I think this is a little bit backwards. Are you telling me you don't have 2 wires sticking out of the front of your house where your doorbell goes?
No, we don't.
What? Why not?
I know, right? Well, I think there might have been at some point, and there was still a transformer in the basement,
right,
connected to nothing, and it was hot when you touched it. And I'm like, oh, how many decades has this thing just been burning
times 2
electricity? Watts. Yeah. So I took that out. No, there wasn't a cable going to it anymore. So I think maybe when they put the vinyl siding on the outside of the house, they took it off or something. When we moved in, they had a wireless doorbell that had D batteries in the receiver. Right. And the D batteries had leaked and then dripped whatever is in D batteries down the paint. And you can, we tried to clean it up where you painted. If you know where to look, you can still see where that drip was. But then we got a different wireless doorbell, and the outdoor button would die. The battery would die once a year or something. You'd never know when it died, because how often does it ring? So in this case, I think it makes a ton of sense to not have batteries in these things that aren't hardwired to your house, because it's just so wasteful, and it apparently needs a mind-bogglingly small amount of juice to squawk out the code to the receiver.
All right, coming up, an Arduino with a floppy drive. This is one of these hacks that I might just have to redo because it's so absurd. David Hansel has actually pulled off a 3-way hack here. It is in one, a library for driving floppy drives. So it's a Arduino floppy drive controller library, Arduino FDC. Then he combines that with Chan's FATFS file system, and then that gives you Arduino DOS, which is actually, you could type in directory to your Arduino and it will go fetch it off of this drive. And to make it even easier to store things on your diskette drive, because I presume you don't have one on your computer, because I know I don't, you can actually X-modem through the Arduino and write directly into a file on the drive itself. This is just absolutely hilarious that you can take a like dirt cheap Arduino clone and an old floppy drive. You just cut up the cable. It's one of those however many pin, 38 pins, 36 pins, too darn many pin cables, and plug it directly into the Arduino, and his library takes care of the rest. And the rest is all those funny low-level floppy drive controlling things, like turning the motor on and moving the seek head around and all of that. And his library takes care of that, abstracts it up to a point where you can just say, read me the data from this sector, and in your code store that into a buffer somewhere. And this makes it possible to have, essentially infinite storage, or however much fits on one of these little floppy drives. What is that, 1.5 megs or something? That's really not much.
1.44, I think was the number on those.
You do better with an EEPROM.
Oh man, I got to clean out my basement. I know I have a box that has some of these in them downstairs. And I just looked, this computer does not have a floppy drive in it. I know I have one somewhere in the house.
I've got 2 floppy drives in my closet right up there.
Do you still have discs?
Try this. Yeah, I do.
Do you still have discs? Yeah,
I do.
I think I've got some discs too. This is not voodoo technology, right? Especially when you have all of these signals, it's actually a little bit easier, I think, than when you're talking like serial drives. And if you want to really drill down and understand how something works, like this is the project to do it on.
That's the point here. You can look through his Arduino floppy drive controller code, and it makes it really obvious how floppy drive controllers used to work. And I agree. I used to think this sort of stuff was magical, and now I've just browsed through his C code on GitHub, and now I get it.
I think implementing FAT is interesting. Now, I've used some libraries, but I still haven't done that myself, and that's kind of always been one of those, someday projects, just because I'd like to have a better understanding of how it's set up.
I tell you what, that is a project that has had some legs. Chan's FAT file system. I have seen that used in so many other projects. Like every small microcontroller project that logs to an SD card ends up just stealing Chan's FAT file system library and implementing it.
I am a sucker for paper encoding, Elliot, and this project is the base level of awesome on paper encoding. It is ostensibly an I2C paper tape reader. It uses a comparator along with what must be a couple of reflectance sensors to read I guess I'd call it a clock timing strip. So it's just checker, white, black, white, black, and then a data strip. And then it's connected directly to an I2C LCD screen, like a character LCD screen. And so you can encode your data that is the commands for the screen, and it'll show up as words on there. And the demo is, hello, tape I2C.
I'm going to go on a rant here, so say something else nice before I do.
Elliot, what do you think about this one?
You bastard. So I looked at this and I was like, oh, that's really cute. This is probably a great way to understand I2C from the ground up, right? Because you're making the black and white stripes on the thing itself.
Yeah.
And then I'm scratching my head and I'm like, wait a minute. The confusing parts about I2C isn't the timing. I guess there's that start and stop bits where the clock and the data shift out of phase with each other. But other than that, it's basically just a clocked serial protocol, except there's that whole mess with the bus. And because I2C uses one line for data, there's this complicated dance between the chip that's controlling the clock and then the device out on the outside that's responding to the clock signal. And after every byte of data, the one of these two devices that's receiving has to ACK it. And then when the one driving the clock and asking the questions is done, it has to send a NAC. And this is where mistakes happen. Chips don't quite talk to each other. They get hung up on the bus and, the whole I2C thing goes to heck. And so if I were to put on my pedant hat, I would have to say, this is not I2C at all.
Yeah, I saw that in the notes, and I'd like you to expand on that because I think it is. So the tape is the controller. The tape's controlling the clock. The screen is the receiver.
The screen's the receiver, and the screen can't act the tape.
The screen does act, though.
The tape can't wait until it receives an act from the screen. The tape is a piece of tape.
Well, the tape is a deaf receiver.
The tape is the clock controller. Controller has to wait until it gets this act from the peripheral, but you keep pulling that tape as if you just didn't care.
The act comes from the screen, and I would say that the screen responds fast enough that the act is received before the tape sends the next level change.
Nope. The tape does not respond to that signal. This is not I2C.
What is the tape supposed to do?
The tape is supposed to be a device that sits there and waits until the counterparty, until the peripheral pulls the line low to acknowledge that the data has been received.
I would argue that the tape does wait for that because the tape is much slower than the screen, and so it happens before you get to the next edge on the tape.
The agreement with I2C is that the clock controller has to be able to pause up until the peripheral says, okay, I'm ready to handle this now.
So what we really need is an ACK light, and then the person pulling the tape, if they see the light come on, they'll wait for that light to go off. Or they'll wait. How does it work? You'd wait for the light to come on, I suppose.
That's right. You would have to wait to see a light to keep pulling the tape. That would work. An
ACK light, yeah.
That would work.
Not a backlight, Elliot. An ACK light.
Okay, I buy that. That'll work.
I do like the simplicity of this one because it would have been incredibly easy to just put a microcontroller on here and read directly. And that's what I would have done. It would have been like the wrong thing because in this case, and I was really glad that Chris linked to this app note from TI, LM393 comparator chip that's used on here can be used in a Schmidt trigger mode so that you have specific levels that you need to meet for the logic output to actually change. And so you get this tape input that's pulled by a human that doesn't necessarily have, really good edges electronically to it, but then the screen is going to see really, really clean logic coming out of the chip.
I should mention the only reason I'm batting on about this particular problem with the ACKs and the NACs and the bus nature of I2C is that this is actually why I hate I2C. I wrote a column a long time ago, What Could Go Wrong I2C edition, way back in 2016. And it dives deep into this whole mess with who has to acknowledge whom when and what the restarts are all about. And that's where the bodies are buried. That's where your I2C bus is going to hang. That sort of stuff, unfortunately, isn't doable with the paper tape, except for Mike's clever ACK light. I like that. And bringing up the rear, I've got a $50 CNC machine. And this is a CNC router for $50. And I'll tell you what, it's not the best. It's probably the slowest, but it actually works. And to watch this video is pretty amazing. Daz, D-A-Z, has pulled off a CNC machine with the bare minimum of parts. $50 budget, I don't know. You need a 3D printer to do it. And but everybody's got a 3D printer nowadays, right?
You cut me deep, Elliot.
Oh, dude. Dude, I've got two. I'll send you one.
Yes, mail me one. That's definitely worth it.
It'll for sure be worth the postage. But what I really love about this is that it has 3D printed plastic linear rails in it, and they've actually got recirculating ball bearings, except the ball bearings are made out of airsoft pellets. And so this machine actually kind of has linear rails on it, although they're plastic ones, so they're not going to hold up to super much strength. And I think that's the big limiting factor here, is that the frame's made out of wood, the linear rails are made out of plastic. You're not going to be able to really just drive this thing blindly through a sheet of aluminum. But if you're careful and you take light passes and you respect the machine's wiggling here and there, you can get away with a heck of a lot. And that's what I love about this build. It looks like it's a start, right? Once you've got this thing working, you can see where its limitations are and start to tweak here and tweak there.
Yeah, and I think that it's almost like the rep wrap approach to CNC. So
Bingo.
now you can start slowly replacing the parts. If those rails do wear out, you might decide you use it enough and is important enough to you to actually buy some, precision rail and start upgrading from there. But I'm with you. I'm surprised this thing worked at all. When I was watching the video, I was like, this has got to be April Fool's.
Yeah, well, he's managed to cut chipboard and do some light engraving in some harder woods. But if you can cut chipboard, you can make the next version of this machine. And, like you said, rep wrap it. You could start building up the next one. And it reminded me tremendously of those CNC machines that Homo Faciens Norbert was building. And so I'll throw links to those in there. I absolutely love those. I've had the good fortune to see some of his completely self-built CNC machines in person, and they're really marvelous. He's doing things here like cutting encoder wheels, with a pair of tin snips. His machines have absolutely no 3D printed parts in them, but are significantly heavier and bigger, maybe about the same speed, but a lot more capable than Daz's machine. But looking through any of these projects should be enough to convince you, if you're kind of like on the edge about a DIY CNC machine. They should convince you that it is certainly within the realm of possibility. Take that baby step and then improve. You'll be surprised where you'll be in a year.
So I think the stepper motors on this, Elliot, isn't this the same type of steppers that we saw on the ticker tape printer last week?
These is absolutely horrible geared stepper motors.
But then they're modified to be bipolar.
Yeah, that's a great hack. Yeah, you just clip out the middle wire and you run them that way. I have done that with every single one of those motors that I've used because I must have read about it on Hackaday somewhere, right? But that is absolutely worth doing. It doubles your torque and those things need it. Yeah, but running a CNC machine with them is just bonkers. Bonkers.
First up on my list, lamps double as secret surround sound speakers. This is a really interesting hack by Peter Waldruff that takes some table-side lamps on either side of your couch, puts speakers in them, and like the lampshade attaches to the speaker body itself, and then you just get a couple of strips of white LEDs on either side, and so the lamps still work, but you have a way of hiding away the unsightly surround sound speakers on your system. Next up, pool temperature monitor mollifies fortunate but frustrated children. I like this one because it's a cool floating sensor. It's just a length of PVC pipe that's been capped on both ends. It has some ballast on the bottom and a foam ring around the top so that it always floats in the same orientation in your pool. And then there is a matching e-paper display that you would put in your pool house, I guess if you have a pool, that shows the temperature of the water. And finally, ASCII schematic diagrams. Sometimes I see these in like the README file of Git repositories, and I assume people are making these schematics that are dashes and pipes and stuff like that themselves. But here is a tool that Chris Lott came across. The original tool was by Andreas Weber, or maybe that's Andreas Weber, and it was written in Pascal, which is worthwhile to no one these days. And so it was nice to see Chaos Ordered updated into a Python package. If you want to put some pinouts for your projects on the top of your README files, this would be a great tool to do it.
All right, my first quick hack this week is the provocatively titled Silicon Carbide Chips Can Go to Hell. Al Williams wrote this one up. It's a project by Alan Mantooth, University of Arkansas, along with colleagues from the KTH, Royal Institute of Technology. The hell here in question is Venus, and the idea is that if you want to design chips that can survive in the 590 degrees C atmosphere of Venus, you're going to have to think hard about it, and silicon carbide looks like the way to go. This is one of those where doing science in ultra extreme environments involves rethinking everything. Like all your solder is going to melt, but even your chips won't be able to handle it without some new technology. It's really cool to see these frontiers being pushed. Next up, Sagara Banana has come up with a device I've never seen before. Feel what the temperature is like outside without leaving your bed. It's a clock, and it's a beautiful little clock. It's activated by knocking on it, and a little piezo inside senses that you've knocked it. That's really cool just by itself. The coolest part is it has a little metal plate on it that's backed up by a Peltier element that becomes the outside temperature after you've knocked this thing to life. You know, maybe you've just moved to a place where you don't know what Celsius or Fahrenheit is. Is it warm outside? Is it cold outside? You can actually feel it by putting your hand on the thing. Useless, lovely, brand new. I'm all over it. Last up, Frank's Enjoy an ASCII version of the Star Wars in the palm of your hand for May the 4th. Came out, well, on May the 4th. I don't know if you've seen Simon Jansen's ASCII version of Star Wars, but it's absolutely phenomenal. This is an homage to that. Frank has put the entire ASCII version of Star Wars onto an ESP8266, displays it on an OLED screen, and has a big magnifying lens over it so that you can read it. This is just lovely hack. Oh, and before we go, I have one more. It's not really a quick hack. An epic quest to put more music on an iPod Nano 3G. Tucker and his friend Wesley have pulled the 8 gig memory off of this old iPod Nano and replaced it with a 16 gigger. They've got it almost working, but they need a little bit of firmware help. So if you're interested in helping them out, click through here, get in contact with them, and get to iPod Nano hacking.
It's time for our Can't Miss Articles of the Week. This is long-form content written by our excellent Hackaday writers, and this week I picked one by Dan Maloney entitled Genetically Modified Mosquitoes, Biohacking for Disease Prevention. It's universally known that mosquitoes spread disease. Malaria is the one that a lot of people think about, but there's Zika and a ton of others out there. What's the bone-hurting disease, Elliot? What's that one?
I'm a hacker, Jim, not a doctor.
Yeah. It's, I can't remember right now. Dengue fever.
Ooh, okay.
There's Zika, there's dengue fever. You know, there's a lot of problems for mosquitoes. Plus, I just don't like them, Elliot. I hate having mosquito
little
bites.
Bloodsuckers.
Yeah, they're always, you get them buzzing around your ears. Like if you lay down in the tent when you're camping and then you hear that zzz.
We went up one summer to the Adirondacks, and they are like little hummingbirds. And it's like a swarm of these horrible little Oh, this is the worst.
Yeah, and Dan's got a story in here about going somewhere where signs were actually posted that the mosquitoes were particularly bad in their area. And inconveniences aside, this is a huge health crisis in a lot of parts of the world. And so solutions are being found. And one of them that's been talked a lot about is controlling the populations through genetic engineering. And there is a test being carried out right now in the Florida Keys that has done just that. So they have altered this line of mosquitoes and they have added into it a new type of protein called TTAV. And this protein, it prevents the females from maturing to an adult age unless they are given a certain type of antibiotic. And so that makes it self-limiting. The males of the species will be able to get to adulthood and will be able to mate with native female mosquitoes and then carry on this genetic change. However, because then you'd think, oh, well, complete collapse of mosquitoes then once you release them. Tests have proven that this line of males is actually not as hardy as the native males. And so they die off after about 10 generations, which means if everything goes according to plan and these mosquitoes are introduced into nature, the strain will die off after about 6 months.
I have to say, I was super skeptical of this in the beginning because, frankly, almost every man-made introduction of a new species or altering of a species has backfired and gone horribly wrong. So why would this be an exception? The whole thing about the antibiotics in there regulating expression of this gene, if you think about it, it's the only way they can breed up these bugs that have the wrong gene in them, because otherwise, if you can't suppress the action of this bad gene, they won't grow up and reproduce because, well, that's the whole point of it. And so you have to have a way to be able to kind of turn it on and turn it off. And I think that's really clever. I do hope that it's true that the males with the bad genes do get outcompeted out of the environment, because like you said, it could lead to complete collapse of all mosquitoes if it went wrong. And I guess the other thing I don't know here is like what eats mosquitoes? For what kind of animals are mosquitoes
Right.
a food source? And is this going to be frogs? Is this going to be dragonflies? Is this going to be, I don't know what's eating mosquito larvae for a good source of protein. And so I can see this having unintended consequences, I guess. If it is true that just not doing anything makes this mutation go away in the wild, then I guess it's okay.
Well, yeah, I mean, if you have a collapse of ecosystems because of this, like if all of a sudden the mosquitoes are gone and then something else relying on the mosquitoes isn't able to eat, like huge waves of horribleness. And I think that it becomes a David Brin novel from that point on out. And I think that that's really easy to foresee, and it would be incredibly negligent if the research scientists hadn't, looked into that cause. And so, although it's not necessarily covered in this article, I have faith that that's not going to happen here. I did find it interesting that Dan says each clutch of eggs from one female is between 100 and 200 eggs. So you can see how those mosquitoes are produced so quickly. And they also think of there's this like stock footage of, I don't know, 1950s America, suburbs, where they have these trucks driving down the street fogging for mosquitoes, and like the kids are out in the front yard playing as these fogging trucks go by, and I'm like, oh. So I mean, there are other bad things going on that we're doing to try and control mosquitoes, and using petrochemicals is not great either. And I think there are wider environmental impacts of that. So I would hope that we could figure out how to do. This seems like a more targeted thing if it works as intended. I would also like to point out there are other efforts out there. Like one of the top award winners on the 2020 Hackaday Prize was a device that you put in standing water that it's solar powered, so it can tell what time of day it is, and at certain times of day it will introduce like perturbances to the surface of the water, which make it impossible for the larvae of mosquitoes to continue developing. And so I think that this is a great effort. It's not going to work in every case everywhere, but there are other applications of technology that we can put forward to try and, make a difference in this area.
Next up in Can't Miss Hacks, exploring the world of Nintendo 3DS homebrew, Tom Nardi has bought himself a 3DS just because the open source community has taken the device up, gotten an unlocked firmware running on it, and that allows you to run whatever programs you want. And there's a vibrant community of people out there porting open source games and other games to this device. And when you've got something like that, it just makes Tom have to buy one. And I thought what was really interesting about this is that the 3DS, which has two screens and was kind of, Tom makes the claim that it's the last of the really portable Nintendos because it folds in half and it can fit in your back pocket, has gotten more expensive since it has been canceled, partly because of this open source firmware effort on it. It's become a more desirable platform now, even though it's been discontinued by Nintendo. So I think that's kind of awesome. Getting 3DSs from one region, say Japan, and running them in another, say the US, is not allowed unless you swap the firmware out. So you can switch up this firmware and then run games that you legally own in America that you couldn't play on a Japanese machine and vice versa. All in all, it looks like a really kind of fun playground. And, when I see things like this, it really tempts me too. I'm glad Tom got to it first.
Well, and he's doing this because the resale market for this discontinued hardware is actually above retail price when they were selling it. And they just stopped selling it, I think, 2019, like a year ago.
Year and a half ago.
Yeah. And so it's really incredible to see that. And he noticed that the Japanese version, which is not necessarily playable because the on-screen menus are going to be in not just a different language, but different characters on the screen.
Right.
And he does mention that it's non-trivial you can do it. You can reflash it and get the region change. It's a little involved to do that. but mentions that to get the ability to run homebrew code on it is actually pretty easy and just done through an SD card slot. That is actually, in this case, the cartridge slot for these things. So I have never had one of these. And to me, I was thinking of like the Game Boy cartridges where it's, the gray plastic square. I didn't really, obviously I know that the Nintendo Switch is an SD card. I always worry about losing the games, Elliot. Because, if it's like the Game Boy size, even that is a little bit small. If it's like the NES size, you are never going to lose an NES cartridge. You're always going to be able to find that somewhere.
That's right. You trip over it.
That's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment on the show notes, which you'll find at hackaday.com/podcast. You can email us, editor@hackaday.com. We live and die by the tips that you send us. So if you see something cool or you've done something cool, please let us know about it. tips@hackaday.com. And until next time,
keep on hacking.
Perfect. I don't know if I have anything to add, man. You said everything. Are we actually talking about things today?
How can we roll this up? What do we got?
What else did we talk about for too long? All right, quick hacks.
Let's do it. Hats off. Hats off. Da, 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 da.
Ba-doom-tsh.